5.2 continues with verifying trig identities. So I was just going to go back through some of your tools and work out a few more examples for you if you would like to see them. So one of our first steps is always to rewrite with sine and cosine. It really helps if you're stuck and you're not sure where to go. Do make sure you're always looking for those Pythagorean identities. Factoring or even factoring out something is also something that we tend to miss, but is available for us a lot of the time. Multiplying by the conjugate, that's when you have a plus or minus in the denominator, whereas splitting the numerator is where you have a plus or minus in the numerator. And then common denominator would be if you have a fraction added or subtracted to either another fraction or just something else. The first thing that stands out to me in this one might be that I'd want to split my numerator because of this minus sign happening in the numerator. However, standing out even more important is the squared here. Now I'm going to look at my Pythagorean identities and I'm going to see that secant squared minus 1 is the same as tangent squared. So I can change my numerator to tangent squared theta. My denominator is still secant squared theta. And this still equals sine squared theta. From there, I want to go back to that first tool we talked about, which was rewriting everything as sine and cosine. So tangent squared is sine squared over cosine. Secant squared would be 1 over cosine squared. Still equals sine squared. If it helps, when you do this, rewrite it over to the side so that you have sine squared theta, or in the next step even, but sine squared theta over cosine squared theta. And instead of dividing by 1 over cosine squared, that's multiplying by cosine squared over 1, and that might help you see that your cosine squareds cancel. You might be able to see it here. But I am left with sine squared theta equals sine squared theta. Now that my left side equals exactly the same thing as my right side, I am finished. On this one, I see fractions standing out to me, so that's going to be the first thing I need to deal with, is combining these two fractions. So I'm going to find a common denominator, which would be, if I multiply those, that should be 1 minus sine squared theta. So I'm multiplying this first fraction by 1 plus sine theta, so this becomes 1 plus sine theta in my numerator. The second fraction I multiplied by 1 minus sine theta, so 1 times that is 1 minus sine theta. Let's see, 1 plus 1 would be 2. Sine theta minus sine theta, that's going to cancel. 1 minus sine squared should stand out to you a little bit because 1 minus sine squared is in fact cosine squared theta. And just like 1 over cosine would have been secant, 1 over cosine squared would be secant squared. I have 2 of these, so it's 2 secant squared theta. Left side matches the right side exactly, so I'm done. Tangent squared theta plus 1 times cosine squared theta minus 1. I see a lot of squareds happening there, so I'm going to just see if maybe I can simplify this. So I look at my Pythagorean identities, and tangent squared theta plus 1 is actually secant squared theta. Cosine squared theta minus 1, if it helps, you are looking at this Pythagorean identity. If I bring my 1 over so that it's cosine squared minus 1, and then of course taking my sine squared over so that that's all that's on that side, I end up with a negative sine squared on that side. Definitely already much more simplified. From there, I need to rewrite this using sine and cosine. So secant squared is 1 over cosine squared. Negative sine squared would just be negative sine squared. And then I'm looking for a negative tangent squared theta. I'm putting that over 1 just so we can kind of see what you multiply, but if I multiplied that over, I'm going to have negative sine squared theta over cosine squared theta, which, since I know that sine over cosine is tangent sine squared over cosine squared would be tangent squared. It is negative because I had a negative over positive. Now that my left side and my right side say exactly the same thing, I am finished. Notice I did not touch my right side at all. Not saying that you'll never touch the right side, but you choose the most complicated side, and 90% of the time you're only working with that side. On this one, I am doing tangent plus cotangent, which while those do kind of go together, adding them doesn't really help me. So I would go ahead and rewrite this as sine and cosine. So I have sine x over cosine x plus cosine x over sine x. Not messing with the other side. Fraction plus a fraction should always, whether you're doing trig or just adding two fractions, lead you to finding a common denominator. Fastest way to find that may just be to multiply your two denominators. So this first one I multiplied by sine x, so sine x times sine x becomes sine squared x. Second one I multiplied by cosine x, so cosine x times cosine x becomes cosine squared x. Oh, sine squared plus cosine squared, that's 1. Can't really simplify my denominator any. I'm just going to bring it with me. 1 over cosine is secant. 1 over sine is cosecant. So now I have that my left side says the exact same thing as my right side. Cannot stress this enough. I have maintained my equal sign all the way down. It's very clear to follow my work. I'm not jumping all over the place. Every transition is clear. On this one, you could argue with me on which one you'd want to mess with. I personally think the right side looks a little more complicated, so it's the side that I'm going to mess with. So I'm going to leave secant x plus tangent x alone. I have a subtraction happening in my denominator, so my tool says to multiply by the conjugate. So I multiply both my numerator and denominator by 1 plus sine x. Up here I'm going to have cosine times 1 plus sine x. If I distribute that, I'm going to have cosine x plus cosine sine x. So I'm just going to leave that as cosine x times 1 plus sine x. In my denominator, 1 minus sine x times 1 plus sine x is going to give me 1 minus sine squared x, which 1 minus sine squared I know is cosine squared x. I need to make sure I'm bringing down this secant x plus tangent x with me every step. Oh, now that I have cosine over cosine, that cosine will cancel one of these out. So I still have my secant x plus tangent x. And now in my numerator I have 1 plus sine x. My denominator is just cosine x. Now that that plus sign's up in my numerator, I can split my numerator. So I'm going to have 1 over cosine x plus sine x over cosine x. And keep bringing down that secant x plus tangent x. 1 over cosine x is secant x. Sine x over cosine x is tangent x. So now my left side and my right side both say exactly the same thing. Okay, for this one, both sides look pretty bad. So I'm just going to go ahead and start with my left side, and hopefully I can simplify it down. If not, I may have to jump over to my right side. When they both look bad like this, I do try to just focus on one side, see what I can do. If I get stuck, I stop and go to the other side. So the first thing that stands out to me on this left side is that I have that plus sign in my denominator. So I'm tempted to say let's multiply by the conjugate. But before I get crazy with that, this cotangent squared is kind of standing out to me. And if I look at my Pythagorean identities, that's the same thing is cosecant squared theta minus 1, which may not seem simpler, but it does at least match the trig functions of my denominator, so I'm going to try it. If it doesn't work, it doesn't work, and that's okay. Since it matches, oh, you know what? Cosecant squared minus 1, that's the difference of two squareds. So I could factor this to cosecant theta plus 1 times cosecant theta minus 1. I'm going to still have 1 plus cosecant theta in the denominator. 1 plus cosecant is the same as cosecant plus 1. So those are going to cancel. And here I have cosecant theta minus 1. Which I could, in a matter of just a couple of steps, rewrite this so that it matches this. I will say it doesn't totally jump out to me a whole lot. Like I might just say go ahead and rewrite with sine and cosine, and then find your common denominator. That is totally an option. I want to show you another option. If you had started on this side, you probably would have started by splitting your numerator. So I have 1 over sine theta minus sine theta over sine theta. 1 over sine theta is cosecant theta. Sine theta over sine theta is 1. To get from there to this left side probably never would have happened. However, since I've already messed with the left side sum, and I got to cosecant theta minus 1, I messed with the right side sum and got cosecant theta minus 1. They do say the exact same thing, so that would be an option. So when you get stuck with these, mess with one side. If you get stuck on it, that's okay. Stop where you are. Don't erase everything. Try the other side. Maybe you can mess with them both to get them to match each other. Do just make sure you're messing with each side independently. So never bringing one thing over from the other side. Another quick recap of our tools. We're writing the sine and cosine, always checking for Pythagorean identities, factoring, multiplying by conjugate, finding a common denominator, and splitting the numerator.